Hello and welcome back. Today we begin solving problems on relations and functions. Slowly we are getting deeper and deeper into elective mathematics. Okay, so first of all we look at relations or mappings. Okay, so for example when given a particular set of items like E, F, G, and then we draw another set of items here, let's say A and B. All right, so let's see whenever uh, you apply some kind of operation, something on this, you end up with this. All right, so like an input here, so think of here as an entry and an exit. All right, so when I put this in here, I can get, say, this. When I put this in here, I could get this. All right, so whenever sets are related like that, we can do what we call mapping them together. And mapping them together is ideally what I'm about to do right now. So we put those cells that are the inputs, for instance, on the left hand side, and then you draw an arrow to show that on the output this is what they result in, and that's a mapping. So we say E maps to A. Similarly, F can also map to A. F maps to A. G maps to B. To B. And that's really what mapping is. Okay. Now we realize that whenever, for instance, a function is given, okay, so, and then it's similar to binary operations. From binary operations we learned that they could say, for instance, A star B is equal to A plus B minus 2AB, for instance. Okay, now right now we can, this whole thing, we can actually just call this let's say a particular machine. So let me draw this machine. I'm drawing is the best machine ever, a nameless machine. Okay, so this particular machine, all it does is it takes two values, A, B, okay, and then what it does is it adds A plus B, and then it subtracts 2AB. Okay, that's what this machine does. Minus 2AB. All right. Okay, so let's say anytime we put in, so it only takes A and B. Watch this. So this particular machine only takes in A and B. So we can write A, B on one side like this. And now we look at the output. So let's say on the output, when it's A, on the output could be 1, 2, 3, or 4, for instance. In this situation, so we'll have this mapping to either 1, 2, 3, or 4. So A could map to that, B could map to that, right? A could also map to that, but then we'll talk about when a particular mapping can be called a function and when it can't be called a function. Okay, and so on and so forth. So this is mapping, basically. All right. So after briefly explaining this, let us solve some real questions, and these are from objective questions. So they said, so we are asked which of the following mappings are functions. Okay, so we have I, E, F, G, and then we have A, B here. So we have this mapping to that, we have this mapping to that, and this maps to that. Okay, first of all, let us understand again what a function is. Like I said, think of a function as a machine, some kind of machine. All right, so I'm going to just call it a machine called F, and it takes in some input values. Okay, it can either take, so from based on this, it can either take E or F or G. These are inputs, and then when we put this through F, something comes out, and according to this, A and B comes out, meaning whenever you put E in, you either get A, and maybe F, you get B, and of course from here, E gives A, so meaning whenever you put E in the function, it outputs A. So that's what they mean by this particular arrow. Alright, it goes straight to A. Similarly, whenever you put in F, well, let me make this capital F so we can distinguish from this. When small f goes in it, A comes out. So the output of small f is A. So that's how come we have that. And G outputs B. Okay, so this is how you should understand a function. So like a machine that takes something and then it does some manipulations and then brings out an output. It's very important to understand it this way. All right. Okay, now that we have that, let us write the rest of the question down and then try to answer it. But if this is a past question, I don't recall the exact date, but then it is past. And then X, Y, Z. So A maps to that, C maps to Y, and C maps to Z. And then third one, we have E, F, G maps to M, C. So E goes to M, F goes to C, and G goes to C. Okay, and then IV, we have A, B, C, and K, L, M, N. Right, so this goes there, that goes there, and this goes here. So L has nothing. So the question was, which of the following mappings are functions? Which of them are functions? So now, there is a particular characteristic that a mapping must not have in order for it to be a function. Okay, so first of all, some terminologies. You see the sets that is usually on the left hand side, these sets, this is usually called the domain of the function, whatever the function is. What do we mean by domain? That means that these are the only input values possible. Remember when we drew the machine? So when we drew the machine, we drew it this way. So there's some machine. Then we said these are the inputs. So taking this for instance, E, F, G. So these are the only inputs this machine takes. It doesn't take H or I or Z, no. based on this particular expression, there's a function, this, which takes only E, F, G, and then outputs. So after E, it outputs A, and then F also gives out A, and then G gives B, and outputs this. Is that clear? Now, before this particular machine can be called a function, before that, each element in the domain, so each element in this domain, okay, must map to one element in the codomain. So if this is called the domain, this is called the codomain. Okay, let me just briefly clean out this question and just take us through these mapping terminologies and stuff. All right. So let's say we have A, B, C maps to E, F, G, for instance. It's simple mapping, really. Okay, so this is called the domain. Remember, think of domain as input to the function, and then this will be codomain. Think of it as output from the function. Okay, now the codomain, sometimes we can have, let's use ABC again, but this time it will be mapped to K, L, M, N, and A will only map with this, B will map with say M, and C will go with L. Okay, again, this is the domain. The domain is A, B, C. But now, of course, we have the codomain, which is just every single thing, K, L, M, N. Remember, regardless of whether or not one of the outputs can be possible from the inputs, this is just the codomain. All right. Now, of course, clearly we can see that one of the elements is actually not affected by, one of the elements in the codomain does not result from the domain. So excluding that, we now have another term called range. The range is only those output elements that arise directly from the inputs. Is that okay? So range gives you all possible values that a function can give you. Okay? And then the domain gives you all possible inputs that the function can take. All right? So domain goes into the function, and then what comes out is the range. All right? But remember, the range is within the codomain, because there might be an element such as this which does not form a range. Okay? All right. So now, okay, now that we understand the terminology, what doesn't make a function? Let's see. If I just remember one thing, right? Each element in the domain must map to only one element in the codomain. So that is the definition of a function. So a function, when you have mappings, only those mappings whose domain, where every single element in the domain maps to only one element in the codomain. For example, if we have A, B, C, right? K, L, M, N. Again, you can just have this. Alright? We can see that every element maps to a unique value which is different from the value of this. In fact, not just that, each element maps to only one value. So what's the result that A will give you after going through the machine? It will only give you K, one value. What's the result that B will give you after going through the function? It will give you L, one value. Similarly, C will give you M, one value. Okay? Now, what if we have something like this? So, say we had A, B, C, for instance. Then we have Q, R. Then during the mappings, and you see that A maps to this. And then A again maps to this, A alone. And you see this here and that here. Now this is not a function. Why? Because one of the members of the domain gives two items in the codomain, both Q and R. Alright, this is unacceptable in the world of functions, if you like. Okay, so this is basically what you need to remember. So now that we remember that, let's go back to that question. So which elements, which mapping is or are functions? So again we have E, F, G, A, B, and that, and then that, right? Then A, C, X, Y, Z, and then you have A maps to that, C goes to that, and that, and then 1, 2, 3, E, F, G. We have M, C. So you have this. Sorry. This and that. And then finally 4. You have A, B, C. Then you have K, L, M, N. Forgive the noise in the background. There are some wild dogs next door. So you have this, and then this goes upward, and this comes right here. So which of these are functions? So first of all, I'm just going to check which ones are functions. This is a function, that is a function, and this is a function. But this is not a function. Why? We can see that every single element in the domain gives only one in codomain. E maps to only one element, which is A. F maps to only one element, also, which is A. So you see that these over here, what they can map to can be equal, but each of them must have only one, right? Okay. And then G maps to only one element, which is B. In this particular case, A maps to only one element, which is X. So that's good so far. But C, you can see that two arrows are proceeding from C. It maps to Y and at the same time Z. Based on this cannot be a function. Okay? And similarly, E maps to only one element, which is M, and F maps to only one element, which is L. G maps to only one element, which is L. So this is a function. And the rest follows. A maps to only one element, which is M. B maps to only one element, which is K. C maps to only one element, which is N. So you see that it doesn't matter whether the domain, all of the domain, all of the elements in the domain are used or not, right? So we can have one element not used. However, we can't have one or more of the domain elements unused. No, we can't have that. Here's what I mean. So for instance, A, B, C, D. 1, 2, 3, 4. Right. So let's see this, there, right? So something like this. We cannot have C not mapping to anyone. So this is not a function. Because even though each element maps to only one, but then one of the elements in the domain is not mapping to anything. So because of this, it is not a function. So take note of that as well. Okay. This was introductory in nature, which is good. So let's solve an actual question on the mappings, which is also from past questions. So again, which are functions? I'm just summarizing the question. And okay, they now asked another question here, which is 1, 2, 1. We'll come to explain that. First, let's deal with which is function. So here are the mappings: 0, 1, 2, 3. 0, 2, 4, 6. So we can see this maps to this, this maps to this, this maps to this, and that maps to that. So clearly, let's just do it along while we move along. So clearly, this is a function because every single element maps to one element, and there is no element in the domain that is not used. So this is a function. I'm just going to say S function. And then the second mappings we have 1, 2, 3, 4. Mapping to 2, 4, 8. So we have 2 to the 4. And then, sorry, 3 to the 4. I was looking elsewhere. We have 1 to the 2 and 4 to the 8. So now is this a function? Yes, this is a function, because every single element in the domain corresponds to exactly one element. 1 corresponds to 2, 2 corresponds to 4, 3 corresponds to 4, and 4 corresponds to 8. Okay, so this is a function. We mark it. 3. So we have 1, 2, 3. 1, 2, 3, and then 1, 3, 5. So this is just straightforward like this. And again, this is also a function. And then we have now 2, 3, 4, 2, 6, 8. And so this maps to that, that maps to that, and then 4 maps to this. Now, is this a function? Yes, this is a function, because 1, every single element in the domain maps to only 1. So 2 maps to 2, maps to 6, 3 maps to 6, 4 maps to 8. We don't see something like this. So for example, 3 mapping to this and at the same time mapping to somewhere else. No, we didn't see that. Alright, so that is what we, so that's how you determine which particular mappings are functions and those that are not. Alright, so now let's do the second part. It said which is one-to-one. What is a one-to-one function? Alright, first of all, this is the only this and that are the two one-to-one functions. Alright, so this is a function and one-to-one function. Okay, now they are one-to-one because every single element in the domain maps to another element which is not shared by any other element within the domain, right? So the value that this y maps to is unique. The value that this maps to is unique. It is not the same as this. So these ones are not one-on-one, not 1-to-1 rather, because 2 and 3 both map to 4. So this makes them not 1-to-1. Okay, so that is it. So that's how we determine. Similarly here, this one is not 1-to-1 because 2 and 3 both share 6. Good. Now students easily make these mistakes, so you should take notes, right? For functions, let me just clean. So for functions, right, every element in the domain corresponds to only one element in the co-domain. Now, for one-to-one, every element in the domain corresponds to only one unique element in the codomain that is not shared by any other element. All right. So this is basically a few definitions you should take note of. Okay, so I'm just going to wrap it off. I'm sure you understand it. So let's move on and then go to the third questions. So they said you have a domain G is equal to this set minus 3 minus 2 minus 1 0 1 2 3. Alright, so we have to draw arrow mappings. Draw arrow mappings defined by I. X maps to 4x plus 3 and I x maps to x squared minus 1. So let's just do these right here. So 1, x maps to 4x plus 3. The mapping is given by, we've been given our domain to be minus 3, minus 2, minus 1, 0, 1, 2, 3. Okay, so now what we do is we find the codomain, in fact the range, to exact the range, because what we are going to do now is going to ensure that whatever we find here is mapped to, it's not missed. So which means sometimes the size of the codomain will be equal to the size of the range, all right, and sometimes the range will be less than the codomain. Okay, so how do we now complete this side? Of course, they've given us the domain, which we've written here. So we replace each of them by x and find out what they will map to. And then we just do it, all right? So for 3, we have x maps to, x is 3, so minus 3. So minus 3 maps to 4 times minus 3 plus 3, right? This is 3 minus 12, and this is minus 9. So this maps to minus 9. Alright? If you have any questions, you can just leave them below. Okay, so now x maps to 4x plus 3. Now we have minus 2, so this maps to minus 8 plus 3. And this is equal to 3 minus 8 is minus 5. So this gives minus 5. Similarly, x plus 3, so minus 1, so 4 times minus 1 plus 3, which is 3 minus 4, and this gives minus 1. So we have minus 1 here, right? Now 0. So 0, when we put 4 times 0 plus 3, this gives 3. So 0 gives 3. And that's how you basically just do the rest. So you see that it's not that hard now, is it? So x maps to 4x plus 3. This is equal to 4 times 1 plus 3. And this is 7. So you have 7 here. Then we now put 2 in there. 4, 2 plus 3. We have 8 plus 3, which is 11. And then we can now have 3. So we have 4, 3 times 3 plus 3. We have 12 plus 3, which is 15. So we have 15. Alright. So this is the range, the entire range of the domain that has been given to us, this domain. This domain. Alright. Okay. So now the question said we should draw arrow mapping. So we just do it. Just draw arrows. Arrows. Sorry, this is meant to touch 7. These lines are not drawn to scale. I hope you can see that. So this solves I. Alright? So we do the same to the II. I might do it a little faster. If you have a question or comment or complaint, leave it below and I will surely answer it. Alright. So now x maps to x squared minus 1. Right? So now we do it. Again, the domain is the same. Minus 3, minus 2, minus 1, 0, 1, 2, 3. And of course the outputs will be kept here. Alright. So this maps to x squared, which is minus 3 squared minus 1. So here minus 3 maps to minus, and this is equal to 9 minus 1 squared, right? Yes, 9 minus 1, which is 8. So this maps to 8. Alright? So we do the same thing. Minus 2 maps to minus 2 squared minus 1. And this gives 4 minus 1, 3. So this gives 3. This minus 2. And now minus 1. Right? So minus 1 maps to 4 times minus 1 plus. No. Sorry. Made a mistake. Okay. So this gives minus 1 to the power 2 minus 1. This gives 1 minus 1, which is 0. So this side gives 0. Alright. Now, of course, when solving this in an example, you don't have to, in an exam, you don't have to do all these side calculations to show. No, I'm only doing it to enhance your understanding of it, right? So when we now substitute in 0, x maps to x squared minus 1. When x is 0, we have 0 squared minus 1, which is minus 1. So this is minus 1. Okay? Now we put 1, 2, and 3. So x maps to 1 squared minus 1. And this is 0. Similarly, x maps to x squared, which is 2 squared minus 1. And this is 4 minus 1, 3. 3. Now watch this. We could have just written another 3 here, right? And then another 8 here. But we won't. We are drawing mappings here. So these other ones give 3 and 8 just like this. So you just, when drawing the arrow, you join them this way. This is definitely this. But these two, they have to go all the way up. So this goes to 3 and 3 goes to 8. And this is how that is done. I hope this was clear. Alright. So now, of course, the question they now ask, was that which of the two mappings is 1, 2, 1. Now we saw that the mappings of the first one was 1 to 1. This is definitely not, because we see that minus 2 and 2 are pointing at the same value. So we can't have that. But for 1 to 1, 1 for 1, no sharing. Okay. Alright. So that solves the question. Now let us begin touching on functions. And I'm just going to do that briefly. Say 2 questions on functions, and then next time we come and continue. So we have a problem like this. A function, and by the way, this is how I abbreviate my function, fxn, is defined by fx gives 3x minus 2 divided by x plus 4. So now this is how functions are defined, right? Remember I said a function, you should think of a function as machine. You should still do so, okay? So this statement means that there is a function called f. So this is the name of the function. It is such that it takes any value x and then it does this to it. It multiplies by 3 minus 2 and divided by x plus 4. So that is all this means. The first one is the name of the function, which is f, and then colon, the variable of the function. It can be anything, it can be a, b, c, y, and so on and so forth. All right, and then when it maps, it forms that. Okay, and now also the function can also be written as this, called f of x. So this is the same as that. All right, and this is equal to 3x minus 2 divided by x plus 4, just like the question said. All right, so now that we understand the notations, let us just jump right inside and solve this question. So a function is defined by this. Okay, what do we do about it? On the domain, okay, so they've given us a domain. On the domain, and the domain is the same as the first one. 1, 2, and 3. Okay, all right. So then, what's the question under it? Find the images of the following elements. Find the images of the following 0, and I'm just going to pause and do it. Okay, so when they say you should find the images, right, each element in the codomain are called images. So just so you see that, this is the domain mapping to FGH. Right, this is the codomain, which is range in this particular case at the same time. But each element is an image of this. This is an image of this, and this is an image of that. Is that clear? So that's what we mean by image. So what this question basically means that we should take each of the values given and find what the function will give. So meaning when you put this value in f of x, what will come out, and that's what you report. Okay, so let's do just that. Let me free up some space. Okay, so the first part of the question said A0. So you find the image of 0. So f of 0, remember, even though questions will usually bring f of x in this form, but I will encourage you to always write it as this, equals 3x minus 2 divided by x plus 4. So now we substitute 0 as x in this situation. So we have 3 times 0 minus 2 divided by 0 plus 4. So this gives minus 2 divided by 4 and is equal to minus 1 over 2. Okay. Let me just do it a little more nice. So minus 2 over 4, which is equal to minus 1 over 2. Okay. So that was that was A. Sorry, it's part of the question, not. So this is A. Now B. It says minus 1. So you basically do the same thing. Minus 1. So f of minus 1. So you see, I just put in this here to show that I'm going to substitute the minus 1 directly. So I say 3 times minus 1 minus 2 divided by minus 1 plus 4. And this is equal to minus 3 minus 2 minus 5 divided by minus 4 minus 1 is 3. So this is the image of minus 1. Similarly, C was 3. So you basically do the same thing. F of 3 is equal to 3 times 3 minus 2 divided by 3 plus 4. And this is equal to 9 minus 2 gives 7 divided by 7, which is equal to 1. And so on and so forth. So for the image, when they say find the image of this from this function, you just substitute that value inside that function, and whatever pops out is your answer. Okay, so let us stop here and then return next time to continue solving more questions on functions. So till then, peace.